Everything has been tested thoroughly. Thomas Jefferson's robot, the destroyer of the new age, is ready to take on the competition.
Welcome everybody to Dallas Fest 2004.
You hear the noise of the basketball-type stadium. You hear the music pounding. You hear the buzzer sound. All of the stuff is just so exciting.
The atmosphere right now is just wow. I'm nervous. I'm excited. There's every possible feeling I can have right now. I've got it.
They're all butterflies, but boy, when that sound off starts, those kids are in there and ready to roll.
Yeah. Alright, let's go, dude.
It's a group effort, and everybody ends up just working together like a family. It's like we just become so close.
Get yourself plugged in, make sure you got control. Alright.
I made a lot of friends doing this. Just coming in here gives me a life lesson. You meet a lot of new people, you make friends. Just a lot of fun.
You guys ready?
Hands down, a great effort by everyone involved. And team members here at TJ are already talking about how they're going to do next year at Dallas Fest. For Schools on Dallas, I'm Edward.
What's going on, you guys? My name is Daryl, and we're here where it all happens, behind the scenes in the control room of Calculate This. Thanks for watching today's show, and we're just about ready to get started. But first, we're going to go ahead and cover a few simple ground rules, and so we'll head over to my man Ivan for more.
Okay, good luck on your problem.
Okay, ground rules. Let's see. Number one, you have to call in. Pick up the phone, give us a ring, touch the dial. I mean, we want to hear from you, and we get awfully bored just sitting around doing nothing. So call in and be a part of the show.
The number is 972-925-3123.
Take a picture, write it down, just give us a call. Number two, when you do call in, step away from the television. It really hurts our ears and it sends off a really bad tone. See what I mean? So, when you call in, step away from the television. I thank you, our host thank you, and our ears definitely thank you. And another thing, when calling into the show, please do not use cell phones. Cell phones do not work too well with our audio system here in the studio. They give off a really bad signal and we have a hard time hearing what you're saying. So remember, no cell phones. Another thing what all of you out there watching to know is that you could be on TV. That's right, your face could be on the tube. Send us a picture, whether it be an individual photo or a photo of your entire class. We'd love to see you, and so would everyone else out there watching. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculatethis@dallasisd.org. Well, it looks like it's just about time for the show to get started, so I have to say goodbye. But don't forget to call in for your chance to win all sorts of cool prizes. So get set for an all-new edition of Calculate This!
Hi, and welcome back to another episode of Calculate This, where we're saving the world one number at a time. I'm Jocelyn Hepburn, lead math teacher for the Dallas Independent School District.
Hi, I'm Jimmy Guillory, and I'm a lead math teacher coach for DISD.
Please be sure to call in today for a chance to win an educational and also a fun prize. Good luck. The number to call is 972-925-3123. Now, let's get started.
Well, before we get started, also for all of our viewers who are experiencing audio difficulties, please turn your television to channel 12B, and it might help you out a bit.
Okay, thank you for that, Jimmy. Well, today we're going to start with Tax Objective 6. And Tax Objective 6 says, the student will demonstrate an understanding of underlying processes and mathematical tools used in problem solving. The students will apply mathematics to solve problems connected to everyday experiences, communicate mathematics through informal and mathematical language, representations and models, and use logical reasoning to make conjectures and verify conclusions. We're going to talk about the four-step method to help solve problems. When we're solving problems, we're going to read the problem carefully. Ask yourself, what is it I'm trying to find here? We're going to plan what we're going to do. What do you do, or rather, what do you know? What operation should you use? Look for some key words to give you the answers to those. You're going to carry out that plan, and then you're going to go back and check your answer. Also, there are some problem-solving strategies that you need to know and use in not only just Tax Objective 6, but in all of the objectives. Act it out. Now, of course, during the tax test, you can't get up and act out, students, so don't try to get up. But you can act it out in your mind. That'd be kind of funny, wouldn't it? Yeah. Okay, make a model. Draw some kind of model that represents what you're trying to find. Draw a picture. Make a chart or a graph. Look for a pattern, and that pattern one is real important. A lot of the things that we do in math deal with patterns. All of them are important, but I just want to point that one out. Solve a simpler problem. When you have a problem that has large numbers, think of a problem with smaller numbers and try to solve that, and then you'll know the strategy to use to solve the one you're on. Make a list. Work backwards, guess and check, and break the problem into parts. Okay?
Those are valuable strategies that, we know that students can use in the classroom, and those strategies, your teachers are probably teaching you and have taught you those, already, so use those.
That's good.
Yes.
That's good. Okay, do we have any callers?
Well, we do have a caller. We have Elijah on the line.
Wow. Hello, Elijah. Elijah's kind of shy there. Elijah?
Hello.
Hi, how are you?
Fine.
Elijah, what school are you calling from?
Atwell.
Oh, Atwell. Good. And who's that? What teacher's that in the room with you?
Mr. Neese.
My good friend,
Mr.
our good
Neese.
friend, Jim. Mr.
Yes.
Neese. Hey, Mr. Neese.
How you doing,
How
Mr.
you
Neese?
doing?
What grade are you in, Elijah?
Eighth.
Eighth grader,
Good.
okay.
We get to start out with a really good problem. Atwell students are pretty sharp, so I'm going to give him a doozy right off the bat. How about that, Elijah?
Okay.
I know you're up to the task. I'm not even worried about it. Okay.
Okay, Elijah, let's look at your problem. It says a pattern is formed using squares. The first four stages of the pattern are shown below. Okay, and if you notice, those four stages, stage 1 has that picture shown there. Stage 2 has the next picture shown. Stage 3, and I think somebody left off the
number.
3. Okay, has that picture, and then our last stage, stage 4, is there. Okay, Elijah?
Yes.
All right, and then the question to this pattern problem is, how many squares will be shaded in stage 20 of the pattern? Okay, and before we start solving that one, this is text 8.16a, and let's read through that and let everyone out there in television land know what we're talking about. And
Okay.
Let's
Did I
see.
mean to write? It's 15, not
Okay,
16.
that's text 8.
No, that's grade 7.
Oh, okay, I'm sorry. I'm looking at the wrong one.
Losing my
All right,
mind.
Elijah,
Jimmy's losing his mind.
we're back with you. It says that the student is expected to make conjectures from patterns are sets of examples and non-examples. Okay? All right, thank you, Elijah.
Okay, Elijah, let's look at these patterns. And when you're trying to figure out a pattern, the first thing you have to figure out are what are the two variables involved. I'm going to write that word right here. What are the two things that are changing?
The squares.
The number of squares and what else?
Stage.
And the stage, okay? So let's make a little chart here, and I'm going to make a horizontal chart. And let's see if we can find any clues as to what is going on with this pattern. Now first, and I'm going to put the 1, stage 1 is the first stage we see. Then we see stage 2, stage 3, and stage 4. Now the question is, how many of the squares will be shaded in stage 20? So first let's see if we can see some kind of pattern forming in what we see here, okay? How many squares are shaded in stage 1? Can you see that? Do I need to zoom it in a little bit?
3 at the top.
I want to know how many squares all together. There's 3 at the top. How many at the bottom?
3, 6, 8.
There's 8 shaded in all together, okay? That's in stage 1, okay? Now what's happening in stage 2? How many are shaded?
12.
12 in stage 2. How many are shaded in stage 3? How many at the top?
16.
16, okay? And how many are shaded in stage 4?
20.
Okay. Now, let's see if we can figure out what the pattern is here. First of all, to get from stage 1, we're going to look up here. Let's start up here with these. No, I think I did it right the first time. To get from 8 to 12, what do you do?
Add.
Add what? I'm going to zoom in a little bit.
Plus 4.
Plus 4, okay. To get from 12 to 16, what do you do?
Plus 4.
Okay. To get from 16 to 20, what do you do?
Plus 4.
So in other words, it's a constant rate of change. It's changing at the same rate as we go along in our y's. This would, by the way, would be our y's at the bottom. These are our x's at the top. Okay? Let's see what's going on with our x's. To get from 1 to 2, what's the change?
1.
Plus 1, okay? From 2 to 3?
1.
And from 3 to 4?
1.
Okay, I keep getting these pens that are running out on me. That's why I'm changing colors. I'm trying to be colorful. So we know that there's something going on with 4s, okay?
Yes.
Now let's see if we can figure out what the starting place point is. We know our rate of change is 4. So in other words, whatever x is, we're multiplying by 4 because that's what rate means. The rate would be the number in front of the x. In other words, for, lack of a better term. Now let's see what our starting place is. Now using this same pattern, if I were to put a 0 here, this would still be my plus 1 here. Right? From 0 to 1 is plus 1.
Yes.
What do I need to put here to continue my pattern? I need a 4. So in other words, my starting place is 4. And how do we represent starting places in equations?
4x plus 4.
4x plus 4. So my equation is y equals 4x plus 4. Do you remember talking about equations in your math class earlier in the year? So that's how our rate of change is the number that goes here. And being an 8th grader, I know y'all are talking about rate of change and slope, right?
Yes.
And also talking about what? Y what?
Y-intercept.
That's right, y-intercept. Very good. So that's how I figure out what my equation is. I figure out my rate of change, and I know that my rate of change, which is the same thing as my slope, is going to go in front of the x. Okay? And then I figure out my starting point, which is where my y-intercept is. In other words, when x is 0, what is y? That's my starting point. So this is my equation. And that equation should work no matter what the stage is. Does that make sense?
Yes, ma'am.
If I'm going too fast, let me know.
No, you're doing fine.
Okay, good.
You're doing
Thank you. He said I'm
fine.
doing
Great
fine. I
job.
take that as a compliment. Now let's see if it works, okay? Let's see if our equation works. Because remember we said on our four-step method we're going to check. So let's see if the equation works. If I put a 0 here, what's 4 times 0?
0.
And 0 plus 4 is what?
4.
And that's what I got, so that works. Let's try the 1. What's 4 times 1?
4.
Plus 4 more?
5.
4 plus 4?
8.
Okay, I knew you just were thinking ahead.
Good job.
But that's fine, I knew you knew the answer. What's 4 times 2?
8.
And 8 plus 4?
12.
Okay, that one works. What's 4 times 3?
12.
Plus 4 more?
16.
That works. What's 4 times 4?
16.
Plus 4 more?
20.
Now notice I went through everything on the table, because guess what? They're going to try to trick you sometimes. First 2 or 3 might work and that next one doesn't. So I always check with everything on the table. But have we answered our question? Our question is, no, we haven't. Our question is, what happens in stage 20? Now that I know the equation, can I figure out stage 20?
You can do 4 times 20,
Okay.
and that'll equal 80. And plus 4,
Okay.
and that equals 84.
Very good. So how many are going to be in stage 20?
84.
84. Of course, we have the little free response grid here. We have to put it in. Let me zoom it in a little bit. Now tell me how to put this 84 in this grid.
You're going to put it to the left of the decimal.
Very good. Very good.
Elijah is
Left of it,
doing great.
he's got it going on like a pot of neck bones.
You got bubble it in.
Okay,
Okay.
got to bubble in the 8, and see, I had numbers this week, so I'm going to make sure I get the right numbers to bubble in. You know, I kind of went off a little bit because I didn't have numbers there last time. But Elijah, I'll tell you what, you did the problem of the day. That
You
one
sure
was
did.
a doozy, okay?
Okay.
But I want you to remember that anytime you have patterns, look for the rate of change and go from there to figure out the pattern. Rate of change, figure out your starting point, and then figure out the equation. Once you have the equation, you can figure out, we could have figured out how many were in stage 100 if we wanted to.
Exactly.
Okay?
Okay.
All right.
Good.
Thank
Did a
you
great
very
job,
much.
Elijah.
Okay.
Bye-bye. Well, that was a tough problem. We do have another call on the line.
good,
We have
good.
Guadalupe.
Hi, Guadalupe.
Hi.
Guadalupe's talking. Before, haven't you?
Have you called in before, Guadalupe?
I can't hear them.
You have. Okay. We thought we
She said you can't-
recognized.
She
the
said
name.
she can't hear us. Can you hear? Let me pull this up a little bit. Can you hear us now?
No.
Then how did you know to say no? That's funny. Okay, can you hear me now?
Yes.
Okay.
What grade are you in, Guadalupe?
7.
Seventh
Seventh.
grade.
Okay, good. You know what? I want to go ahead and do another pattern problem since we're talking about patterns.
Good
Now,
idea.
the one that he had was a real easy pattern to see. But this one is a more difficult pattern. So sometimes you're not going to, an easier way is what I'm trying to say, is to figure out the table and go from the table to figure out what your next move will be. Okay?
All right, Guadalupe, let's look at your problem. It says Micah is using marbles to form a triangular pattern. The diagram below shows how Micah built the first 4 stages of his problems. Okay? I'm sorry, of his pattern. I'm not reading well today, very well today, Guadalupe. Okay, look at stage 1. How many marbles do we have there, Guadalupe?
1.
1. Okay, what about stage 2?
3.
Okay, 3, and then stage 3, how many are there?
6.
And then stage 4?
10.
Okay, all right, so we looked at each one of those stages. Now it's asking us, after Micah completes the 10th stage, how many pennies, and it should
be
probably be marbles, okay? How many marbles will there be in his triangular pattern? Okay, and before we start solving that, Guadalupe, let's look at, this is text 7.15a. It's the 7th grade, and that tells us the student is expected to make conjectures from patterns and sets of examples and non-examples. So it's pretty much similar to that 8th grade text.
Right, and
that we
those objective 6 texts are throughout. They're all
Okay.
throughout, and they're just different numbers, but it's pretty much the same text. But let's see about solving this one, okay? Now, I'm going to zoom in a little bit. I want you to still see your marbles here, and we're going to make a table again, just like we did before. Now we have stage 1, stage 2, stage 3, and stage 4. Now in stage 1, how many marbles did we say?
1.
Stage 2?
3.
Stage 3?
6.
And stage 4.
10.
Now this one doesn't have a constant rate of change like the other one did. See, if I go from 1 to 3, I'm adding 2. If I go from 3 to 6, I'm adding 3. If I go from 6 to 10, I'm adding 4, and so on and so forth. But I can use that pattern to figure out the 10th stage. The 10th stage is a lot quicker to get to than, I think it was the 20th stage on the other problem. But if I look at what's going on with this problem, I see that to get to the next number, I'm adding the stage number plus how many were in the preceding stage. You see what I'm saying? So for stage 2, I add the 1 from stage 1 plus stage 2, and I get 3. For stage 3, I add the 3 from stage 2, which is the same as the 2 and the 1, to get the 6. So it's 1 plus 2 plus 3 to get 6. To get this one, it's 1 plus 2 plus 3 plus 4 to get the 10. So in other words, what's happening here? You're adding the stage number plus what? Guadalupe? You want me to go over it again? Let me go over it again. To get this number here, if I add, well, let me go ahead and add it, because that might be what's going on with it. Okay? First I'm in stage 1. So stage 1 was 1.
I can't hear.
Oh, you still
Are you
can't
still
hear?
having problems?
No.
Okay. Can you hear now? Okay.
Okay.
So for stage 1, I just had the 1 marble. In stage 2, I added the 1 marble plus 2 more, and that gave me 3. Okay? So it's the stage number plus how many marbles are in the stage before that. For stage 3, I added the 1, the 2, and now I'm going to add 3. That's stage 3. Now do you see what I'm doing?
Yes.
Does it make sense? So for stage 4, what happened? 1 plus 2 plus 3 plus what?
4.
Okay, so what do you think stage 5 is going to be?
10 plus 5
That same thing plus 5. And stage 6?
plus 6
And stage 7?
plus 7
Stage 8?
plus 8
Stage 9?
plus 9
And stage 10?
plus 10.
And that's the stage we want, right? So all we have to do is add up all these numbers, and we'll figure out how many are going to be in stage 10. You think that'll work? Sure it will. Let's go ahead and add. What's 1 plus 2?
3.
3 more?
6.
6 plus 4?
10.
10 plus 5?
15.
15 plus 6?
11.
15 plus 6? 15 plus 6 is 21.
Good.
21 plus 7?
28.
28 plus 8?
36.
36 plus 9?
45.
And 45 plus 10?
55.
55. So how many should we expect in stage 10?
55.
55 marbles. Okay? Now if nothing else helps, if you get a problem like this on the test, you can always draw marbles. And count the marbles. Okay? Now, of course, that's another free response question. Oh, that's an easy one. We're not going to worry about putting it in the grid.
Okay. You did a great job, Guadalupe.
Excellent job. That's another doozy. Okay?
Yes. Thanks a lot for calling.
Patterns can really throw you if you let them. But you have to figure out what's the best method. On one of them, using the equation, solving an equation was the best method. Remember when we talked about the different, let me put that back up, the different strategies.
Yes,
on the first problem, it was solve an equation. Is that not one of them? Solve a simpler problem. Oh, I don't have that up there. Anyway, it should have been up there, solving an equation. The other one was make a table or look for a pattern. So either one of them that you want to say. I wonder why solving equations isn't up there. I have to add that on for next week.
Great job. All right, well, we do have another caller on the line.
Good.
We have Diamond on the line.
Oh, good. Hello, Diamond.
Hi.
Hi, Diamond. What school are you calling from?
Johnny Hood.
I think Diamond's called before and won before, right, Diamond?
Yes.
Yes, okay.
What grade are you in, Diamond?
7.
Seventh grade.
Okay.
Good, good. Here's a problem.
Okay, Diamond, let's read your problem. The snacks at a school fair range in price from 50 cents to $1.25. A teacher promised to buy each of his 20 students one snack. Which of the following is the most reasonable estimate of what the teacher could expect to spend for snacks? Okay, and Diamond, before we start that, let's read this text here. It's 7.13a, and 7.13a asks, or it says that the student is expected to identify and apply mathematics to everyday experiences, to activities in and outside of school, within other disciplines, and with other mathematical topics. Okay?
Yes, sir.
All right.
Okay. Now, this teacher has 20 students, and he has some snacks that range anywhere from 50 cents to $1.25. Okay?
Yes, ma'am.
Now, what if all 20 students chose the snack that cost 50 cents? How would we figure out what the teacher would pay?
50 times 20.
Okay, the 50 cents times, not 5 cents. Oh, well, that was 50 cents. I just forgot my decimal. 50 cents times 20. You want to go ahead and let's multiply that, or can you do that in your head? I know I can. Okay.
Let's just multiply it.
Okay.
I'm sorry?
Multiply it.
That's right. Now let's multiply together. We can go ahead and put that 0 down, right?
Yes.
And then 2 times 0?
0.
2 times 5?
10.
Where do I put my decimal?
In front of the 1.
How many numbers are behind the decimal right here?
2.
And how many do I need behind my decimal here?
2.
Okay, so where do I put it?
In front of the 0.
Okay, right here, are you saying? How many, we're going to start from the end. How many is this? 1, 2. Because I have 2 behind my decimal here and none behind the decimal here, that's a 2. I need a total of 2 numbers. I need to add that. 2 numbers behind the decimal. That's how many numbers I need behind the decimal. So there's 1, there's 2. So my decimal goes right there. So how much money is that?
$10.
$10, exactly. Okay, that's if everybody buys the 50-cent snack. Do you think of 20 students, everybody's going to want the same thing?
No.
No, they're not. So it's very, very unlikely that everybody's going to buy the 50-cent snack. Now, keep in mind, it says 50 cents to $1.25. So that means they have some snacks that cost 50 cents. They have some snacks that cost 51, 52, 53, and everything in between up to $1.25, okay? Or could be everything in between up to $1.25. Now, what if everybody picks the $1.25 snack? How are we going to figure out what that total would be?
50 times 125.
The 20 times the 125, right? Okay, I knew that's what you meant. Okay, we're going to put that 0 down again. What's 2 times 5?
10.
2 times 2?
4.
Plus 1 more? 4 plus 1 is 5, okay. 2 times 1?
2.
Now, where am I going to put the decimal?
In front of the 0.
Absolutely. Absolutely. So how much money is this?
$25.
Okay, so if it was $1.25 times 20, that would be $25. Now, keep in mind, once again, we don't know, I mean, it's a very unlikely chance that everybody is going to like that same snack. What kind of snacks do you like?
Ice cream.
Ice cream? Ask the people in your room if everybody in there, if that's their favorite snacks. If they had ice cream and then some other snacks to choose from, ask somebody in there what their favorite snack is. Anybody in the room? Any student in the room?
favorite snack? Ice cream.
Okay,
yeah.
somebody that's different.
Hot Cheetos.
Hot
Oh,
Cheetos.
hot Cheetos, okay.
So if you have ice cream, and maybe the ice cream's 50 cents, I doubt it, and then you have the hot Cheetos that are $1.25. If hot Cheetos is my favorite, I may choose the hot Cheetos over the ice cream. So in other words, what I'm saying is we don't know what those 20 students chose. But we do know that if all of them chose the 50-cent snack, it would cost the teacher a total of $10. If all of them chose the $1.25 snack, it would cost the teacher $25. But our question is, what is the most reasonable estimate of what the teacher could expect to spend? Now let's look at our choices. Now what do you think it would be a reasonable estimate? You think $10 would be a reasonable estimate?
No.
No, because more than likely everybody's not going to like the same thing. Do you think the $25 would be a reasonable estimate?
Probably.
You think it would be reasonable? You think everybody's going to like that $1.25 snack? Even the one that liked
hot Cheetos.
I think I said the hot Cheetos was, even the one that liked the ice cream, but the hot Cheetos was the one that was $1.25. So you think even though they prefer ice cream, they're going to choose the hot Cheetos?
No.
No. So would 25 be a reasonable estimate? The most reasonable estimate, I should say. Okay, we can cross that out. Is $30 a reasonable estimate?
Yes.
You think so?
Uh-huh.
When if all of them got a $1.25 snack, the total would be $25? If all 20 got the $1.25 snack?
No.
Because that's $25 is what? The what?
Highest.
That's right.
Highest,
The
yes.
most of the highest amount they're going to pay. So 30 is not a reasonable amount. Now let's look at the 20. Why is 20 the most reasonable amount?
Because it's higher than 10 and it's below 25.
Absolutely. It's the one that falls between the lowest amount and the highest amount.
I like the
Okay.
way that he stated that
I do
it's
too.
higher than 25, but it's lower than $10.
Absolutely. Absolutely. Well, thank you very much, Diamond, for calling.
Great job.
Welcome.
Thanks a lot. We do have another.
It's a tricky one.
We have another call on the line. Rhea.
Hello?
Hi, Rhea.
Hi.
What school are you calling from?
P.W. Brown.
Oh, from Brown. Okay.
Good. And Rhea, we forgot to ask who was in the room at the other two schools.
Yes,
Damn, you have to help me
ma'am.
remember.
Okay.
Who's in the room with you? What teacher?
Mr. Allen.
Mr.
Mr.
Allen.
Allen.
Hey.
Mr. Allen.
How you doing, Mr. Allen?
That's our good friend.
Yes. Rhea, what grade are you in?
Mr. Allen.
Oh, he said
Oh,
hello.
I'm sorry.
7th grade.
7th grade.
It's not Mr. Allen in the room?
Yeah, he's in the room.
Oh, okay.
I think he was saying hello to us.
Hey,
Yeah.
Miss Allen. So you're in the 7th grade. She said, okay, you already said that. Come on, get off. I'm the one on the phone, right?
Okay, Rhea, we will be going on with the problem. Okay, Rhea, your problem, Rhea, this is a nice problem.
Yes,
It says, let's read this. It says, which algebraic rule is demonstrated, and that word algebraic, Ms. Hepburn may talk about that in a few minutes, okay?
Okay.
Which algebraic rule is demonstrated by the equation shown in the box below? And this is also text 715A, and we read that earlier. Do you remember us talking about that, Rhea?
Yeah.
Okay, great.
It's the one about the patterns, okay? And this one is a pattern. And by algebraic rule, they mean if I state this in algebraic terms, in terms of algebra, what would that look like? And so what you have to do, the reason I say this one's about patterns, is you have to figure out what is it they're doing to get this, okay? What are they doing to this to get that? Because that's what patterns are all about. What do I do to this to get that? Now, we have 4 to the 9th power, and that's a fraction bar. You know that fractions are division signs. So that's 4 divided by 4 to the 9th power divided by 4 to the 3rd power. And we get 4 to the 6th power. Now let's see if we can see a connection here. What do you see in your answer? What's one thing that you see in your answer?
They all have exponents.
They all have
Okay.
exponents. Very good. What else do you see in your answer?
They're all 4s.
They all have 4s. So there must be something about this. These two both have to have the same number. and then in your answer you're going to have that common number, right?
Yeah.
Now, the exponent in our answer is what?
The exponent or answer.
What is the exponent in our answer?
6.
6. Now, can we see a relationship between these two numbers and this number? We have a 9, a 3, and we end up with a 6. So what do you think happened?
They're all multiplied by 3.
Oh, very good. They are multiples of 3. That's good. That's good. Do you see anything else?
Subtract.
Okay.
Let's see. Let me see if that works. You're telling me if I subtract 9 minus 3, I get 6. Is that what you're trying to say?
Yeah.
So in other words, if I get this exponent at the top in my numerator, subtract the exponent in my denominator, I get the exponent in my answer.
Yeah.
And I will just bet that that only happens if these two numbers are the same. What do you think?
Yeah.
Now let's see if that, let me see what that looks like. Let's see, we have 4 to the 9th power, so that's 4 times 4 times, ooh, that's a lot of 4s. 4 times 4 times 4 times 4. 1, 2, 3, 4, 5, 6. Ooh, I don't know if I can count up that high. That's more than I can fit on that page right there. Okay. And then we have 4 to the 3rd power. 4 times 4 times 4. And we're dividing those. Now what is 4 divided by 4?
1.
So that cancels. 4 divided by 4?
1.
That cancels. 4 divided by 4?
1.
So what do I have left?
1, 2, 3, 4. The rest of the 4s.
The rest of the 4s, and how many of them was it?
6.
6. Now, let's look at our choices. Now, in other words, when I have an x, that's why it's called an algebraic rule, because now I'm going to use variables instead of numbers. This first rule is saying, and let me explain the rules and then we'll go back. If I have a number, and it's to the a power, or some power, and I divide that by the same number to a different power, my answer is that number to the top power minus the bottom power. That's my first rule. We're going to come back. Now here it says if I have a number to a power and divide it by the same number to a power, I'm going to get 1 to the a minus b, or to the power minus the power. This one says if I have a number to the a power and it's divided by the same number to the b power, I'm going to get the number to the a divided by b. And this one says if I have a number to the a power divided by a number to the b power, I'm going to get 1 to the a divided by b. Now which one of these matches what we did with the numbers filled in? A, B, C, or D? Well, let's see if we can eliminate some first. Let's make it easy. Tell me something that we can immediately eliminate.
I can't see.
Okay. Well, let me zoom in. Let me zoom in on these two and see if I can eliminate one of these two.
B.
Okay, tell me why I can eliminate B.
Because of the 1.
Because of the 1. On the other one, we had a 4, and we got a 4. Now, they have a 4 and a 4. They get a 1. That's not going to work. Let's look at the other two, see if we can eliminate something.
D.
Same reason, right? So that narrows us down to A and C. Let me zoom it out a little bit so we can see both of those. Okay, now we have A and we have C. Which one of those matches what we did?
A.
A. Okay. And why does A match? Because what did we do here to get this 6? Because we subtracted. Very good.
Good job, Rhea.
That's some algebra you just did. But guess what? You might see a problem like that. I got this problem right off of the, what do you call that? Text, information booklet. Tax information booklet. This was one of the examples on the tax information booklet. So you could very easily see a problem like this on the tax test.
And Rhea, you did a great job because, when you go from those whole numbers like we had there, the base number 4 and the exponents, and then you go to suddenly a variable, some students will get very nervous about that, but you did an excellent job.
She did. She really did.
Thanks a lot.
Thank you so much for coming.
We do have another call on the line. We have Lewis on the line.
Okay.
Lewis is not here, but my name is Ivan.
What is your name?
Huh?
What is your name?
Isaac.
Isaac. Okay, Isaac. What school? Okay. Ivan.
Okay.
Oh, Ivan, just like the Ivan in the booth.
Yes.
Oh, Ivan paid you to say that your name is Ivan. Are you on a cell phone, Ivan?
Yes.
Okay, you know why I knew that? Because we're getting some funny little noises. So if you could step back a little bit from the television, we won't get those funny noises. Okay?
Okay.
All right. Yeah.
Ivan, what school are you calling from?
Huh?
I mean, you're probably calling from home, right?
No.
No, you're calling from school? What school?
Thomas A. Edison.
Okay, from
Edison. Oh, okay. Who's there in the room with you?
Let me tell you what the problem is. The library has a meeting going on, so we have to use the cell phone. And
that's fine. Okay, and who am I talking to?
Here's Ivan back. Here's Ivan back.
Okay, who are we talking to?
That was Mr. Scales, I think it was.
Scales?
Yes, okay.
Mr. Scales expects us to just know who he is. He's not going to tell us the name. And I guess you did know, huh, Jen?
And the reason, Ivan, because of the cell phone, it's sort of like a delayed hearing for us. We can't really hear you because the cell phone is picking up all the noise all over the room. So, you know, we may ask you a question, but we may not get your response for a delayed second or two, and that's why it's not good.
That's a very good explanation there, Jimmy. Well, Jim is an engineer, I guess. I don't know. But that's fine. I'm glad you called in.
Yes.
I'm glad you called in. There was a problem in the library, and they still called in. That's wonderful.
It's exactly. Great job.
Okay, Ivan, what grade are you in? Seventh. Okay. Here's a problem for Ivan.
Okay, Ivan, we have a good problem for you. Okay, Ivan, let's read your problem. It says, Suzanne spent 3 hours and 22 minutes writing her English composition. Maisha spent 2 hours and 48 minutes writing her English composition. How many more minutes did it take Suzanne to write her English composition? And this sort of sounds like the thing that the 7th graders were doing last week, right?
Right, they're writing those English compositions.
Yes. Okay, Ivan, this is text 7.13a and 7.13a. It says the student is expected to identify and apply mathematics to everyday experiences, to activities in and outside of the school, within other disciplines and other mathematical topics. So I think we read that a minute ago.
Okay.
But it's always good to read back over.
Okay, now let's look at our what it is we're trying to find. It says, how many more minutes did it take Suzanne? Okay, key word here, I'm going to put a little box around it, minutes. What units did it give us, time units did it give us?
3 hours.
It gave us hours and minutes. But our answer is asking for just minutes. Here again, it gave us hours and minutes. So what is it we need to do in order to figure out the answer?
Proportion.
Yes.
Okay, we could do proportion. I hadn't thought of that. We can make a proportion. Help me make the proportion. 3 hours. We're going to change hours to minutes. So how am I going to do that?
3/22.
Hours to minutes.
Exactly.
Okay, we're just changing, right now we're just changing the hours to minutes. Okay, let's try another approach. If I have 1 hour, how many minutes are we talking? How many minutes in an hour?
24 hours.
24 hours in a day, very good. Now how many minutes are in an hour? Huh?
60 minutes.
60 minutes in an hour. That's in 1 hour. So how many minutes are in 2 hours?
90 minutes. 120 minutes.
Somebody's giving you a wrong answer there, huh? You had to think about it. You said, wait a minute now. Okay, so 2 hours is 120 minutes. Oops, I have to spell minutes right. And then, so how many minutes are in 3 hours?
180.
180 minutes. Now, what I used there was something called scaling up. A type of proportion. It's called scaling up. So, if it's 3 hours, we're talking 180 minutes. But it wasn't just 3 hours. It was what? 3 hours and what?
22 minutes.
So what do I need to do with that 22?
Subtract it.
You sure?
Add it.
Add it, absolutely. Okay, let's add. 0 plus 2?
2.
8 plus 2?
10.
And 1 plus 1?
2.
So this is Suzanne's time, okay? I'm going to put a little Suzanne there. That's her time. Now, let's go to Maisha. She spent 2 hours and 48 minutes. What do we need to do first? Change what to what?
Change hours to minutes.
Hours to minutes. And how many hours, minutes rather, did we say we're in 2 hours?
120.
Okay, we have 120 minutes plus 48 more minutes. What are we going to do with that 48?
Add it.
We're going to add it. What's 0 plus 8?
8.
2 plus 4?
6.
Bring down the 1. This is Maisha's. Now the question, they're laughing at Maisha. I think that's, y'all laughing at Maisha, aren't you? Y'all laughing at that name Maisha, aren't you? I heard somebody laughing when I said that's Maisha. Anyway, the question is, how many more minutes did it take Susan to write her English composition? Now when we see how many more, what does that indicate? Subtraction. Most of the time that indicates subtraction. So we're going to subtract what?
202.
Okay, minus?
168.
Very good. Let's do that. Can't subtract 8 from 2, so we have to do what?
Borrow.
We have to borrow it. Let's make that look like a 6. Can we borrow from 0?
No.
But we can borrow from what?
Yeah, 2.
Okay, so that leaves a 1 here and makes a 10 there. Then borrow from the 10, that leaves 9 and makes that 12. 12 minus 8 is?
4.
9 minus 6 is?
3.
And then of course 1 minus 1 is 0. So how many more hours did it take Suzanne?
Minutes.
I'm sorry?
Minutes.
I meant minutes.
She means
now
minutes.
You're right. Thank you for correcting me. I meant minutes. 34 more minutes. And that's which answer?
B.
Very good. Boy, it seems like Edison's always correcting me on something.
Well, yeah.
Well, they're sharp over there. They catch it all. They catch it. I like that. I like that.
Mr. Scales, you're doing a great job. Thanks a lot,
Scales
Lewis.
is the one that told you that, didn't he? I think I made Mr. Scales mad when his daughter was in my class. I'm just playing. Just joking with you, Mr. Scales.
Thanks a lot. We do have another caller. We have Nadia on the line.
Okay.
Nadia, are you there?
Hello? We still talking to Isaac. Was it Isaac?
Anyone? Anyone?
Were we still talking to Lewis? That's right.
Anyone?
Somebody wasn't there, and Lewis took over.
Okay.
Oh, we lost Nadia. Oh, man.
Okay.
Poor Nadia.
Okay.
Nadia, call back in, honey.
Yeah. Call us in.
We're concerned. Okay. Now, let's talk about which problem was I want to go back over something. Well, we'll just go to another problem. Let's go to another problem here.
Okay, let's look at this problem while we're waiting for callers. I think that name is Rochelle, right? Okay. On this particular problem, and students just bear with us until we get a caller in. Rochelle is an accountant. Okay, she counted 1,692 quarters. Those are quite a few quarters.
Oh, yeah.
Okay. Which sentence shows the number of dollars these quarters are equal to? And before we solve that one,
I think we got Isaac back.
okay, we do
Hello,
have.
Isaac. So that was Lewis that we talked to. Was it Lewis we talked to
It was.
from Edison? Now we're talking to Isaac. Hello, Isaac.
Yeah.
Okay. Now who was it that called from Edison before?
Ivan.
Ivan. Well,
Okay, Ivan.
I cannot remember Ivan. I think it's because he's in the booth. I think it's
Okay.
because Ivan's in the booth.
Okay, we have someone who works here whose name is Ivan, so it must be a
That must
pretty
be
good
it.
name.
It must be.
Okay.
But anyway, we're talking to Isaac now. Isaac, what grade are you in?
7.
Good, good. We have a problem up. Let's go ahead and read that problem again now that we have Isaac on the phone.
Okay, Isaac, let's just read your problem again. Rochelle is an accountant. She counted 1,692 quarters. Which sentence shows the number of dollars these quarters are equal to? Okay, and before we work on this problem, Isaac, let's look at text 714A. 714A tells us that the student is expected to communicate mathematical ideas using language, efficient tools, appropriate units, and graphical, numerical, physical, and algebraic mathematical models, okay?
Okay, Isaac? Now this happens to be an algebraic model, okay? Because we're trying to get this information in this scenario, this written description, and convert it to an equation, okay? Now, first of all, she counted 1,692 quarters. And we want to know which one of these equations would help us figure out how many dollars that is. Now, when I first looked at this equation, I'm going to tell you, Isaac, I said, you know what, I'm going to figure out a simpler problem and figure out what I would do to figure out the simpler problem. And I said, instead of 1,692, because like Jimmy said, that's a lot of quarters. What if I only had 4 quarters? If I had 4 quarters, how many dollars would that be?
1.
That would be $1, okay? 4 quarters, oh, well, I put it here, $1. Because I ran out of room on the end. What if I had 8 quarters?
2.
That would be $2. How are we figuring out how many dollars that is?
Every 4 quarters is $1.
Okay, every 4 quarters is $1. Now, can we put that in mathematical terms? What can we do to get the number of dollars? What did we do to the 4 to get the 1? What did we do to the 8 to get the 2? We divided, okay? So if I divide 1 divided by 4, I got that backwards. No, I had it right the first time.
Okay.
Wait a minute. No, I'm saying it wrong. If I divide, what did I divide? You tell me what I divided. I had 4 quarters. 4 divided by what gives me 1? 4 divided by what? By the 4 quarters gave me the $1. And here, 8 divided by the 4 quarters gave me the $2. Now, another way I could write that would be 4 divided by 4 like that, and 8 divided by 4 like that. Now, I want to see, now that I've used a smaller number, now that I have my big number, which one of these equations would match this was my process. It was the number of quarters divided by 4 here, the number of quarters divided by 4 here. So which one of those equations matches that process? A, absolutely. The number of quarters, which is 1,692, divided by 4 gives me how many dollars it is. Very good.
Great job, Isaac.
Excellent job. Excellent job.
Thanks a lot for calling.
Thank you.
I'm just good at that.
Oh, good. Yes, you're very good at that. You probably would have given me the answer. I probably didn't have to go all around about it. I had to think about it, but you probably knew right off the bat.
Students know money problems. We do have another call on the line. We have Rigoberto. Rigoberto, are you on?
Hello.
Hello.
Who's calling? Hello.
Nadia.
Nadia's back on the line.
Nadia's back. I think we lost Nadia a minute ago.
Okay.
And I know we're running kind of low on time, so I'm going to give you one that's pretty quick. Okay?
Okay.
Actually, this one's even quicker.
Okay, great. All right, Nadia, let's look at your problem. It says the cost of a special ice cream at the mall is $2.25. Kathy's father paid for 3 special ice creams. Kathy figured that the cost was $5.75. Was she correct? Okay, and before we do that, let's look at text 8.14c. 8.14c says that the student is expected to select and develop an appropriate problem-solving strategy from a variety of different types, including drawing a picture, looking at a pattern, systematic guessing and checking, acting it out, making a table, working a simpler problem, or working backwards to solve a problem. All right, Nadia? It sounded like the whole strategy thing there.
Oh, yes, it did.
Okay.
And this one, we're going to work backwards to, I think it's the work backwards one. I can't remember off the top of my head. But anyway, we just want to know how much Kathy's father is going to pay for the 3 special ice creams. Now, how much did it say that each one of the ice creams cost? $2.25. Speak up just a little bit, okay?
Okay.
How many of those special ice creams did Kathy's father buy?
3.
Now, if I bought 3 ice creams and each of them cost $2.25, how am I going to figure out my total amount?
By multiplying.
Okay, multiplying. And so I can immediately eliminate 2 of these choices, can I? Which 2?
D and C.
Absolutely, because they didn't multiply anything. Now, all I have to do now is figure out which one of these are right. It says, was she correct? No, because 2 times 2.25 is $4.50. Is that the reason she was not correct? I mean, it's pretty obvious it's a no, because that's the only choices we had. Is it because 2 times 2.25 is $4.50? Or is it because 3 times 2.25 is $6.75? Which one of these would be the correct answer?
B.
B, absolutely. Because it didn't say anything about 2 special ice creams. It only talked about the 3 special ice creams. Right?
Yes.
Absolutely. I knew that was one we could get through pretty
Wow.
quickly. She did it. Nadia, I'm glad you came back because you did an excellent job. I forgot to ask you, what school are you calling from?
J.L. Long.
J.L. Long. And who's there in the room with you?
Miss Hoover and Mr. Roberts.
Our good friends, Miss Zuber and Mr. Roberts. Hey, how y'all doing over there?
We saw them in Michigan
Yes,
at that
we did.
Connected
We
Math
saw them
program.
at the Connected Math training in Michigan. They didn't tell y'all they went to Michigan, did they? Oh, they did? Okay. I'm just
great.
checking.
Okay.
I'm just checking.
Thanks a
Okay?
lot, Nadia.
Thank you for calling back.
Bye.
Okay, bye-bye. Well, what are we looking at, like, on time?
Well, I wonder what our time frame is. Do we have time for another caller? Do we have another caller? Okay, we do have time for one more caller.
Okay.
And I believe it's Tony,
Tony?
from North Haven. Now, is
Wow.
that in elementary school? Or? Hello, Tony.
Hello.
Tony, what grade are you in?
7.
7. Now, North Haven, I'm not familiar with that school.
Huh?
I'm not familiar with that school, North Haven.
It's elementary school off of Northwest Highway and Bachman Lake.
Oh, okay.
Oh, okay, okay. So they go from elementary to middle school?
Yes.
Oh, okay, okay. See, I didn't know about that school.
Wow.
Learn something new every day. Well, Tony, I think we have time to do this problem. Well, that's an 8th grade problem. Let's try another problem. I think I saw a 7th grade problem. That's 8th grade, 8th grade. Well, we have at least one. Well, all of them are 8th grade, so we may as well do this one.
Exactly.
I think Tony can handle it. North Haven sounds like a really sharp school. Tony, who is there? What teacher's there in the room with you?
Mr. Manning.
Mr. Manning. Hi,
Okay.
Mr. Manning.
Hi, Mr.
It's nice to meet you. We got to go over there and meet
Really?
Mr. Manning so we can say Mr. Manning's our friend too, Jim.
Exactly.
Everybody's our friend. But in the
Okay.
meantime, we want to work here with Tony.
Okay, let's read your problem, Tony. It says Kelly gets 5 cents for each empty bottle she returns to the supermarket. How many bottles must she return to earn $5.50? Okay?
Okay.
And I think we've read that text. So let's go ahead and see if we can work the problem.
Okay.
She wants to earn a total of $5.50. And for each bottle, she gets 5 cents. So what is it I'm going to have to do to figure out how many bottles it's going to take me to get to $5.50?
Yes.
Okay, what do I need to do? You want to try a simpler problem?
Yes.
Okay, let's try a simpler problem. Okay, let's say I have each bottle I'm getting 5 cents. I want to earn 50 cents. How many bottles do I need to sell to get 50 cents? If it's 5 cents a bottle.
In box 3?
Well, we can do a simpler one. What if I want to earn 20 cents? And each bottle is 5 cents a bottle. How am I going to figure out how many bottles I need to get 20 cents?
Subtract?
Did you say divide?
Yes.
Okay, I can divide that 5 cents. How old are you anyway?
13.
13?
Okay.
Okay, that voice is sounding a little bit husky there. But 20 cents divided by 5 cents gives me the 4 bottles. So now I have $5.50. How am I going to figure out how many bottles?
going to divide
it.
Okay, divide what? Divide by what is what I'm trying to say.
5.
5 cents. Okay, since time is pressing, we're going to go ahead and use the calculator to do that division. Is that all right?
Yeah.
Because we're going to run out of time if we don't.
Okay.
So we have $5.50 divided by 5 cents. And we get how many bottles?
11.
How many is that?
111. No, 11 cents. 110.
110 bottles. And then, of course, we have a free response grid here. Do you know how to put that on the grid?
Yeah.
And how do we put that on the grid? How do we put it in the grid?
On the, where you're, right there.
Okay. What do I put right here? What do I put?
The 5, 0.5.
The 0, the 1, and the 1, right?
Yeah.
Okay. Good job. Thank you so much for calling, Tony.
Thank you, Tony. Okay.
Tony had a ball with us, didn't he?
Okay.
Tony's 13.
Yeah.
Okay. That's just about all the time we have today. But before we go, we have to do what, Jimmy?
Let's see. Give away that educational and fun prize that we
Okay, so
have
who's
here.
the lucky person?
Well, the lucky person is caller number 8 from Long, Nadia.
Nadia from Long. Oh,
Great. Congratulations,
Remember,
Nadia.
we love to see you. So don't forget to bring pictures to your teacher so she can send them to us. Our email address is calculatethis@dallasisd.org, or you can also send them through interdepartmental mail to DISD Box 379.
Thank you for joining us today on Calculate This, and we'll see you next Tuesday. Same time, same place on Calculate This. Bye.
Alright, we hope you've enjoyed today's edition of Calculate This. It's been a pleasure bringing it to you. And as a quick reminder, don't forget to send in photos of yourself and your class. We love to be able to show your face on television. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculatethis@dallasisd.org. And if you'd like to find out more about the show, check out our website at www.dallasisd.org/calculatethe. For all of us here at Dallas Schools Television, I'm Daryl, and we'll see you next time on Calculate This. See you then.